Dear ladies and gentlemen, I would like to present you our work named Compliance Control of Parameters during machining on CNC equipment using industrial IoT and digital twin. The content of this presentation is mostly typical. At first, it will be a statement of the problem. After that, we will analyze some tools we can use and choose some tools. After that, we build a process data flowing and some explains for this data flowing. After that, we describe some methods for testing results and made conclusions. This work started because of experience of using enterprise resource planning named ERP system on aerospace industry company. Modern quality standards for aerospace industry requires tight control for all process. In this article, we focused on the requirements for the product's manufacturing process, in particular, guarantee and proof that all operation during the was carried out exactly in accordance with the technical documentation, minimizing and negative impact of human factor. So the typical technical process consists of technological operations like cutting, heat treatment, CNC, manual machining, special process, etc. Controlling the fact of execution sequence of operation in semi-automatic or automatic mode is not a problem on this moment by any system. But it is a challenge how to control the parameters inside the operation, especially if it is complex operation such as CNC machining or special process. So our article studied instruments for collecting, processing, store data from IT device and analyze it. The challenge of our article is to build fully integrated chain, like in this slide, started from high-level MPS plan to the end of decision-making system through all the chain. We will describe it below. So available tools we can use. At first is ERP system. There's many ERP system on the market. It can be a big ERP system like an SAP, BAN, Microsoft, Dynamics, etc. We used IT Enterprise ERP from Kyiv, Ukraine, in our research. So the next stage is an important stage, is a PDM system. It's a best choice when a PDM system is a subsystem of ERP. It because we have integrated resources for PDM, for plants, and for all. So really, it's a big choice. And of course, we use PDM module of IT Enterprise ERP too. And of course, we're using all type of plans, starting from main plan, MPS plan, and calculated plan like MRP and APS-MES planning in IT Enterprise too. So next step, it was how to collect the data from CNC machines. In our example, it was CNC machines, but it can be not only CNC machines, it's meters and something else. With meters, we can collect the data. So it is in our article describes many available instruments data from IoT devices. We used IT enterprise instrument for IoT, and we tested self-developed application to gather information from CNC control like Fanuc, Siemens, and Hand-in-Hand. It was example. So we developed this process flow, data flowing. Let's detail it. At first, the source data we have is a main process plan that we know which product we want to make on which data. And of course, we need to have some PDM system. In this PDM system, we understand the sequence of operation. We understand how much time needed for every operation. And we have all information about parameters of this operation. So the first that ERP system have to do is to make some calculation to receive the equipment schedule. It's a big calculation, but it's not a focus in this article because it's another term. So when we have a schedule for some equipment and we have data from PDM, what parameters on this operation will be, that we have to prepare the operation. In our article, it is detailed. It is this process is detailedly described, and we have to some actions when prepare an operation, like testing, is it okay, is it on time, and so on. And in this stage, we can stop the operation if it is not so good. If it's okay, we will start the operation and register in IoT that operation starts, and make some processing on CNC. It will be good. It will be next step in our research. How compare the data from CNC control and compare the data from a digital twin of this process. It is necessary to know, because, for example, some tool can be not so sharp as it needed, and detail may be corrupted, for example, in processing. It's not so good for company and the quality. So the goal in the next research is to make online, maybe on-fly analysis of operation flow. So when all operation, if all operation is good, that operation finished, and after that we have to compare at final is was all okay or no. If we register some not good things, we have to transfer data to decision-making system, because it can be various reasons for this. After that, we how operation it was. Can the detail use in aviation industry on any industry or no? So let's go. So the first base aim, to have automatically generated report. It's nowadays many companies make manual reports, and we have to want to have automatically generated reports for this operation. And after that, we want to have ability to get this data to quality management system model. And next step is advanced, is to have on-fly data comparison that I say with source and digital twin. It will be much more better than AIM1, but it is for the next steps on our research. So, what's the time? I built a digital twin model for this operation, and after that we can compare it. The next example is how to look our IoT data after pre-processing. So we can count the cycles of how much details equipment done, and we can see all operation parameters like a rotating speed of spindle and its coordinates and movement speed of this spindle. So it's basic data for with real and with digital twin model. In conclusion, we said that it's very important to define data flow because protocols interface. Because the most of instruments are separately and have some instruments and data inside them, and we want to make integrated chain for this work. So it's important to define data flow on all this chain. We have positive results for testing. As I say, some method of linking all operation data to the number operation in PDM system. And next steps we have to do is complete system of comparing. At first to build a digital twin, and after that to gather all information from IoT sensors, and after that comparing this data and make principles that decision-making system what it to do when deviation occurs. So, thank you. Questions?
Thank you, Sergey, for a very interesting presentation. Dear colleagues, we have 2 minutes for questions. Does anyone has any? Okay, Sergey, I have one question. What is the bottleneck, maybe some disadvantages which are to be fixed in the future of your system?
The bottleneck in our research, we define it, there is a very big volume of we can collect from CNC control, and we have to research how we can pre-process this because we don't need so big data at the moment, and we have to remember that this data flows every second, and if the company have, for example, 100 CNC equipment, the storing and analyzing this data can be a big challenge. So it can be bottleneck that we research.
Thank you. Okay, any questions? No? Okay, agree. That's it for you.
Thank you.
Thank you for your presentation.